Okay, so guys, class of service. So class of service, what have we discovered? So what we discovered is that we have different types of traffic and we have to treat them differently. And there's basically three things that we do to treat traffic differently. First of all, we classify it into a forwarding class. We can allocate it a loss priority, which determines whether it gets dropped or not when congestion occurs. And then once we've got our forwarding class set up, we can then direct the traffic into a particular queue. So let's just have a look at the mechanisms we use for some of those things. So traffic classification. So we've had a look at classification. We've looked at the fact that we can have an in-the-box model using a multi-field classifier, and an across the work model using the multi-field classifier at the edge and the BA rewrite and classifier in the core. We've had a bit of a look at the configuration of those, and we've had a look at how to do the rewrites. Let's take a look at this here. This is a policer. So what we're doing with this is we're saying if the traffic exceeds certain parameters which we set, then we're going to set a particular forwarding class on that traffic. Otherwise, we're going to set a different forwarding class on that traffic. So here's our firewall filter. As you know, we read or filters a process from the top down. So we start off with this policer here, which says if we exceed a bandwidth limit of 1 meg and a burst size of 3K, then we're going to set the forwarding class to best effort. And if we take a look at what happens next, we've now got another filter there where the filter is called apply cost markings. The term is from admin, so if the source address is from this particular subnet, then we're going to apply the policer that we've just set up there, which is called admin traffic policer. And we're going to set the forwarding class to expedited forwarding. And then we accept that traffic. So what would happen to the consequences of that, and of course we're going to accept all other traffic. So the consequences of that is if we exceed this particular burst size here, then the traffic that is sourced from this subnet will have the policer applied, and the forwarding class will be set to best effort. Otherwise, the forwarding class will be set to expedited forwarding. Okay, so basically we're saying any traffic that is out of our profile that we are going to accept, and that profile may be a profile that is just set as what we think might be appropriate for a particular subnet. It may be, if we're looking at a service provider situation, it may be something that's subject to a contractual arrangement or some type of service level agreement. In any case, if it's out of that profile, we're setting it to best effort. So in other words, we're not guaranteeing anything with that traffic. It's going to be on the same footing as every other traffic. However, for traffic that falls within the profile, we're going to set that to expedited forwarding. We're going to treat that differently. We're going to give that a higher priority, and we're going to process that over and above, or we'll give that priority over and above the other traffic. Let's take a look at traffic queuing. So one of the purposes of setting the forwarding class is so that we can map traffic into a queue. And remember, we mentioned earlier that this bandwidth limitation is really all about the buffer size that's allocated to a particular device interface. And if that buffer's full, then we've exceeded our bandwidth. So what we're doing now is we're actually taking that available buffer there and we're dividing it up into different queues. The purpose of that is, of course, so that we can service those queues differently. But let's take a look at, first of all, getting the traffic into the queue, which is our first job. So we're going to map forwarding classes to queues. We have a mapping mechanism here. So this is the show class of service forwarding class, where we've got a traffic ID and a queue ID. In this case, they are the same. Best effort 0, the queue ID is 0. You don't have to do it that way, but it's kind of easier to do it that way. So that's the first job, is getting the traffic into the appropriate queue. So first of all, we've marked up the traffic with a particular marking, and now we're mapping it into the queue. So we can actually go and set up our forwarding class. We can create custom forwarding classes here. So we've got general traffic, important traffic, critical traffic. So we're not stuck with our defaults. We can change that to whatever we want to change it to. Okay, so now that we've got our traffic into an appropriate queue, let's look now at how do we service those queues. So the whole point of having traffic in different queues is so that we can service those queues differently. So we have a scheduler that's going to allow us to determine how those queues are serviced. What can we set up? We can set up priority, we can set up transmission rate, we can allocate a certain amount of buffer space to a queue, and we can set up our RED configuration, our random early detection configuration. So you can look at these first two here. Priority and transmission rate defines the order in which packets are transmitted, and then we've got buffer size defines storage and the dropping of packets in the case of congestion. Okay, so we can have a queue priority here. So here we have, according to their assigned priority, so common priorities are high, medium, medium, high, medium, low, and low. So that's essentially a prioritization of one queue over another queue. So there we are with our 4 queues, each with their different priorities. Service first, service last. We can also go and set the transmission rate on a particular queue. So we've got 40%, so we're going to use 40% of our available bandwidth to for that particular queue. We're going to set a buffer size percentage, 40% of our buffer size, and we can give it a priority of low. This is our best effort queue that we're configuring here. And we can do a show under class of service schedulers, and we'll see the best effort with the transmission rate, a buffer size, and a priority. We can do that for all of our queues. This is the scheduler mapping. Scheduler maps associate schedulers with forwarding classes and queues. So this is us setting up a scheduling mapping, a forwarding class, and applying that scheduler to a particular queue. So if we take a look at the class of service scheduler maps, we've got forwarding class, best effort, and a particular scheduler that we have assigned to the queue. So each queue has got its own specified scheduler assigned to that queue. And we're going to go and apply those maps to our outbound interfaces. So this is our class of service interfaces. We've got GE000 with a scheduler map, and a scheduler map example is the name of it, is what we've given it. So we have then apply the scheduler map to all the fast Ethernet interfaces, in this case, using that second example there of FE-**. And we're applying that map. Now, so essentially what we've done with this process is, first of all, we've classified traffic. We've given it a forwarding class. We've given it a loss priority. We've applied policing to it to say what we're going to do with traffic that falls outside of a particular profile that we're looking at. And what we're going to do is we're essentially going to change the forwarding class or the loss priority. In fact, if you go back up, and I might just dive back up and take a look at that Lisa there we had up on the screen before. dive back up through here. Okay, so where we've said set the forwarding class, we can also go in there and set loss priority at the same point. So we could do that up here in the police cell, we could do that down here in the filter. So we actually do get to set two things, forwarding class and loss priority. In this case, the example is just showing the one, but we can go and set both of those right there. So we get to set that up. We then get to apply that to queues. We then have our actual fabric of our network go ahead and process that traffic accordingly. We get to apply policing on the way out, multi-field classifiers also on the way out of our system, random earlier detection, shaping, scheduling, and we can rewrite that